Welcome to the next step in our introduction to systems engineering in practice. In the last video, we spoke about how to create the initial system architecture and how to utilize different viewpoints of our system of interest to get an overview of the design. In this video, we'll go further into details about how to monitor the integration between systems by utilizing the functional system architecture.
While the stakeholder needs and business requirements are enough to create the initial system architecture, and we can use international standards to govern the structure, it is not enough to develop the more detailed design about how the systems interact. That is often where design fails, so that is also why this discipline is especially important. Because it is an important task, there are also a few approaches to do it. And here there are also software solutions to help the development. A common way to note interactions between systems is to begin sketching them out with lines. Again, there is nothing wrong about this approach, as it is an effective way to consider and write down possible interactions between systems. The pitfall that many people fall in is that they lose overview in the complexity which arises when all inputs and outputs are mapped in a line diagram or SysML model, and this risk grows exponentially with each new systems added to the model. A model is only useful if we can understand and explain it to our colleagues. It is a high priority to maintain the simplicity and overview. The approach we would like to introduce is a more simple and more structured way to visualize this information. We simply list the system in a diagonal. Now we have a grid. And this might look familiar to you. It is actually called an N2 or N-square diagram. It is a visual tool where we can systematically check each potential interface. It works like this. All systems of roughly the same complexity level is arranged in the diagonal. All horizontal cells are outputs from a system, while all the vertical cells are input to the system. The N2 diagram has been a core part of systems engineering since the 1970s, and there's a good reason why. With this map, we have an easy-to-read and easy-to-approach method for checking all potential interfaces and keeping them in control. Let's go through an example. In our example, we want to design a modern vehicle where we can repurpose the heat generated by the motor to heat up the cabin. This information is noted down in the diagram like this. When it comes to the steering, it is connected to the wheels, so we know that we will need some kind of mechanical interaction here. Lastly, the safety system governs how the ABS system works and ensures that we have traction on the drive wave. This interaction is also important to keep in mind in our design. When we have systematically checked both the inputs and the outputs to the thrust system, we can move on to the next system. We have already checked that the steering system and the thrust systems are connected, so let's move on to the illumination system. Here we can imagine that the headlights are adapting direction depending on where we're going, so we need a signal exchange here. And the turn signal also needs to be automatically stopped when it detects we're done turning the vehicle. The last interface we need to map is that the safety system will turn on the emergency lighting if a crash is detected. It is important to note that this method helps us to highlight where we need to consider interactions in the design, but it does not provide any detailed solutions to these interactions. The design of the individual systems should accommodate the identified interfaces. Further analysis using, for example, electrical calculations or 3D drawing tools are needed, but that is a task for the detailed design. One of the many strengths of the N2 diagram is that we can map both where there are interactions and also where there are no interactions. We recommend to fill out the diagram with minuses as well to indicate we have checked the interface and deem there are no interactions. We can also start doing an analysis of which systems are relying a lot on other systems and which ones are working independently. In this example, the environmental control system is not heavily influenced by the design of the other systems. This information is useful to prioritize resources in our development and also to see which systems have the most constraints to adhere to. The next thing we can use the N2 diagram for is grading the maturity of the interfaces. What we often see is that some of these interactions are already well established and implemented in the design because the solution and technology have already been chosen. We can mark these interfaces green. But the other interfaces are not very well described because we're still investigating the design, or we wait for further information. We can mark these interfaces red. We call this the maturity of interfaces because it represents how confident we are in the design and known interactions. In our project, we should allow for gradual maturity of the design through an iterative process by revisiting these interfaces throughout the project. The question marks should be investigated and clarified, and the interfaces which are marked red should be matured into green interfaces, which means they are accounted for and implemented in the design. I want to take a moment to stop here for a second and really underline what we have created here. This is not just a way to track how well our design is doing. It is also a systematic way to visualize and convey really complicated information that normally would reside in the head of a few subject matter experts. This also means that new resources in the project can get onboarded easier, and the project are more immune to reallocation of resources with critical knowledge. There are other uses for the N2 diagram, for example failure mode and effect analysis, but that is a topic for another time. Let's summarize what we have been talking about. Step number 1. Use ISO IC 81346 to create a uniform functional system architecture and categorize the systems. Step number 2. Use the functional system architecture to create an N2 diagram. Use this to systematically check each and every possible interface to make sure nothing slips between your fingers. Step number 3. Use an iterative approach to revisit the same interfaces and systems to gradually mature the design.
Managing and monitoring system interfaces is not a trivial task, but we hope that you have found some inspiration in our practical approach. Remember, practice makes perfect. If you're interested to know how this applies in your project or you seek help to get control of your design, please feel free to reach out or take a look at the description below. Otherwise, we hope to see you in the next video.